Hello everyone, and welcome to our session from Notebook to Kubeflow Pipelines with Hyperparameter Tuning. In this session, we will be showing a complete data science workflow for optimizing your models, and we will be using Jupyter Notebooks, Kale, Katib, and Kubeflow pipelines. This is us. I'm Ilias Katsakioris, software engineer at Arrikto.
Hi everyone, I'm Stefano Fioravanzo, software engineer at Arrikto as well.
At this point, we would like to give some credit to Sarah Maddox from Google, who helped us tons with this tutorial. What's in it for you in this session? What you learn. By the end of the session, you will have converted a Jupyter Notebook to a Kubeflow pipeline with Kale. This makes your workflow a lot easier and faster. You will have performed pipeline-based hyperparameter tuning with caching, which makes your pipelines run faster. Everything will be simple, since we will be using intuitive UIs for everything. You will also accelerate your machine learning lifecycle with Kale as an orchestration tool. And finally, you will gain complete visibility of your training. You can find a slide deck following this link here, where you're also able to win some cool prizes. Although this is a recorded session, we have live Q&A on Twitter and LinkedIn using these hashtags. The machine learning platform we are going to use is Kubeflow. For those who are not familiar with it, Kubeflow is an open source project dedicated to making the deployment of machine learning workflows on Kubernetes simple, portable, and scalable. And how can you use it? You can deploy and manage complex machine learning systems at scale. You can experiment rapidly. You can perform hyperparameter tuning. You can deploy hybrid and multi-cloud workloads. And you can have the so coveted feature of CI/CD, continuous integration and deployment. This is a 10,000 feet overview of machine learning as an ML engineer would look at it. Machine learning requires some tools and frameworks for data scientists. Kubeflow encapsulates applications and services to run those tools on top of Kubernetes clusters. And Kubernetes runs on-prem or on any cloud. And this is a machine learning workflow as a data scientist would experience it. Data science begins with identifying the problem and collecting and analyzing data. Then, the data scientist has to choose a machine learning algorithm and code their models. Subsequently, they have to experiment with data and model training. Then, they optimize their model with hyperparameter tuning. And of course, in the very end, they need to serve the model with the best result. Kubeflow has various components to achieve all the aforementioned. In this session, we will focus on Jupyter Notebooks, Kale, Katib, and Kubeflow pipelines. How can someone use Kubeflow? You have a graphical user interface, a GUI, to manage notebooks, volumes, snapshots, pipelines, etc. This is an image of the central dashboard. Also, you have two command line interfaces, kfctl and kubectl. And of course, Kubeflow has its own APIs and SDKs, and here are some examples: the pipeline SDK, Katib API, and metadata SDK. There's a perception that machine learning is all about model code and complex math, but in reality, machine learning applications are complex distributed systems. They require lots of DevOps and various components for monitoring, serving, managing the resources, etc. Kubeflow containerizes all these components so that you can run them on Kubernetes. Thus, you have a uniform way to run your workloads everywhere. And at this point, I'll hand it over to Stefano.
Thank you, Ilias. So now you've seen how Kubeflow can accelerate and simplify the whole orchestration process of running machine learning workflows at scale. In this tutorial, we're going to specifically focus on the data science experience. So how Kubeflow and the tools we're going to present will enable to dramatically simplify and accelerate the data science workflow, starting from your development environment, that is most often Jupyter Notebooks, then how Kale as a workflow tool will enable you to create pipelines seamlessly and run them in Kubeflow pipelines. And then while doing all of these, ROC will enable you to close the circle, go all the way back from running to developing essentially with complete reproducibility, enabling you to explore your pipelines back in time. So we're talking about pipelines as the core workflow tool in Kubeflow. This is because data science is inherently a pipeline process. Usually, when you do data science, your job, your work consists of several independent steps that come one after the other. These may be data ingestion, and then transformation, validation. Afterwards, you do model training, either locally or at scale, and you end up serving and monitoring. So all of these steps can be combined together in pipelines. Now, this workshop will focus on how to simplify as much as possible the building process of a pipeline directly from your local environment via a graphical-based approach, and how to completely automate data versioning to enable reproducibility and collaboration. Of course, the tools that will make this possible are Kale and Arrikto's Rock. Now, I've been talking about converting a notebook to a pipeline. So this makes a lot of sense, because if you think about it, when you work in a Jupyter Notebook, you are already defining a sort of workflow that is pipeline-based. All of your cells in the notebook can be thought of as isolated steps that can be even combined together and attached to one another with dependencies. This process makes it very easy to parallelize and isolate your code at scale. So you could even easily run hyperparameter tuning over a notebook and its steps. And then also it becomes very easy when running pipelines in Kubeflow pipelines to apply data versioning and reproducibility to all of these independent steps. And you'll see later how this can be achieved. And the various parts of your notebook that become independent steps might have different requirements. So a data processing step might be CPU bound, so it will need a certain kind of hardware resources, while another part of your code that might be doing deep learning training would benefit from running in a node with a GPU. And all of this becomes feasible with Kale and Rock. Let's take a look at how these tools combined together with Kubeflow dramatically improve your development workflow and lifecycle. So traditionally, you would write some machine learning code, maybe in your notebook. But then once you're ready to build a pipeline out of it and scale it up, you would need to create a new Docker image where you package all of your dependencies and your code. Then you need to take your original code, your machine learning code, and actually write a pipeline with some specific SDK, for example, the Kubeflow pipelines DSL. Compile this pipeline, upload it, and run it. Whenever you need to go back because maybe you made a mistake or you need to improve your own code, you need to go through all of these cycles, this cycle again. You need to write again your code, repackage it into a Docker image again and again. But now with Kale and Rock, all of this process becomes much simpler, because you just need to write the code in the notebook, tag the notebook with the UI-driven way. You'll see later how. And with a click of a button, just run it. Whenever you need to amend your code, it's seamless. Just write it in the notebook and click the button again. You can already think how this workflow dramatically improves your iteration time and how much faster allows you to be productive. Okay, so Besides converting notebooks to single pipelines, we'll look also at how to run hyperparameter tuning optimizations. In a data science world, it is usually the case that you are running machine learning algorithms that are dependent on some parameters. So what you end up doing after writing your first iteration of an algorithm is starting to tinkering with the parameters and analyzing by yourself the produced metrics. This is, of course, a very time-consuming process and also error-prone. But then there are ways to automate all of this using some automatic tools that basically use your algorithm and search through a given search space, the parameters that you give in automatically with some specific mathematical optimizations techniques, and optimize over the metrics that you want to optimize. In the case of Kubeflow, Katib is the official hyperparameter tuner. It supports several machine learning frameworks, including TensorFlow, MXNet, and others. And today, what we are going to see is how you can go from a notebook to Kale to Katib, so scaling up your notebook as pipeline with hyperparameter tuning with just a click of a button. And with this, I will hand it over back to Ilias, who will start walking you through the actual tutorial.
Thank you, Stefano. To follow the tutorial, please go to this link to find the corresponding code lab that contains the step-by-step instructions. This is the agenda of the tutorial. We will install MiniKF, then we will get some already cooked machine learning code, explore it, convert to Kubeflow pipeline, and then perform hyperparameter tuning on a specific model. The first step is to install MiniKF. But let's see what MiniKF is. MiniKF is the easiest way to deploy and experiment with Kubeflow in just a few minutes. You can have it on GCP, on your laptop, or any on-prem infrastructure. It is an all-in-one, single-node Kubeflow distribution. And MiniKF, Mini-Kubeflow, is actually Minikube with Kubeflow and our software, Rock, a data management platform. This image is taken from the TFX paper. Kubeflow brings all these parts together in a containerized way and gives you a nice way to perform hyperparameter tuning. Moreover, Kubeflow provides you with an intuitive UI to manage all your components. As we have already mentioned, Kubeflow runs on top of Kubernetes, which takes care of job orchestration. But then you also need to manage your storage. You can use many open source tools or your cloud provider's object store, but MiniKF comes with Rock, our data management platform. We have made a lot of contributions to Kubeflow. Because of our expertise in storage and data management, we have extended Kubeflow, making it data aware. We contributed code so that Kubeflow can use Kubernetes PVCs no matter where it's deployed, on your laptop, on-prem, or a public cloud. Rock takes care of data versioning and syncs your data across all different infrastructures. Let's see why data versioning is important in machine learning. Let's say we have a pipeline where the first step is data validation. When this step is done, we take a snapshot of it, and we do the same for the next step, data preprocessing. Then another step runs, but it fails. How are we going to debug? We can clone the latest snapshot, explore the data and code, and then fix the error and continue the pipeline. Let's now set up our MiniKF. This is the code lab you found before. Here's an introduction related to the workflow we're going to follow. Here are various information for those who are not familiar with Google Cloud. Finally, let's head to the marketplace and install MiniKF. MiniKF is a marketplace solution. We search for it. Click on launch. choose the project we're going to deploy it in. And here are various configurations we can choose for our mini-KF. We can choose a zone, we can choose its disks, we can select GPUs if they are available in the zone, and once we're ready, we can click on deploy. So now the instance is going to come up, and after that, it will take about 15 minutes for mini-KF to be up and running and for you to be ready to experiment. At this point, I'll hand over back to Stefano.
Thank you, Ilias. So in no time, you should have a ready mini-KF, and you will be able to start with the tutorial yourself. Now, I will walk you through the rest of the code lab. So we'll see how you can go from Notebook to Katib to Kubeflow pipelines. So I will head over to my mini-KF. As you can see here, I have the Kubeflow Central dashboard. If you are already used to Kubeflow, if you've already used it, you might notice that the sidebar here is a little bit different. This is because we've been working on the Kubeflow Central dashboard to unify in a consistent way all of the Kubeflow components together in a single place. And you will see how I will be using this throughout the tutorial. Of course, this is work that we are going to contribute upstream very soon. So you will be able to see it in the GitHub discussions. So now I'm heading over to Notebooks. And I'll create a new notebook just for this demo. I'll name it KubeCon. I'm selecting a Jupyter image that includes Kale. Then I'm also adding a data volume. And I press launch, and that's it. This is very simple in Kubeflow to spin up new Jupyter servers where you can work on your own code and start new pipelines. Okay, the notebook server has been provisioned, so I can just connect. And in no time, we have provisioned in a self-serve way a full Jupyter Lab environment. Now I want to clone some code where I can work on. I can do that from the code lab. As you can see here, there are all of the instructions that you can follow at a later stage. Now I'll just scroll here to the code that allows me to clone the Kale repository. So I'll head over back to my notebook. So we are cloning the official Kale repository that is open source. As you can see, there is an examples folder. We're going to open the dog breed classification example that we prepared just for this tutorial. There are two notebooks. We will start with the dog breed one and then switch over to the dog breed Katib. Now, I won't go over into the details of what is implemented in this notebook. Just keep in mind that this code is based on a Udacity project where we are basically processing some dog images and building a deep learning classifier to recognize dog breeds. The first thing I want to do is to verify that my notebook has the dependencies it needs to run the code. So I'll just run the first cell here with the import, and we notice that we are missing some dependencies. So I have a helper here that runs pip install to install the requirements. Notice how I am installing this library here now on the fly. This will be important at a later stage when we will convert this to a pipeline. You can think of this process as I could be tinkering with the code, solving bugs, adding new features, and then installing the dependencies on the fly as I add new code. Okay, so now we should have all the dependencies we need. I'll restart my kernel. Okay, so every import succeeded. So let's say I'm done with the code. I'm done with the code, so I have implemented all my data preparation, and then I'm detecting my dogs. I'm writing some detectors, wrote the CNN and deep learning code to recognize them. Again, I won't go into details, but you see there's some involved code in this notebook. So I tested it locally. I have all my dependencies, and now I want to scale it up and convert it to a pipeline. How do I do that? So I can go over here on the left, click on the Kale panel, enable it, and now you see a whole bunch of things happening. So Kale is a way for you to tag notebook cells in a UI-driven way and assign these cells to pipeline steps. Let's take an example here. Here you see this cell is tagged as step load data. By pressing on the top right here, you see Kale provides a very simple way for you to tag this cell with this specific name. And what you're doing here is basically assigning this cell to a pipeline step. Multiple cells, as you can see, can be merged together in a single one. And then it is that simple to create new steps and dependencies. Once you do this, of course, we've already tagged this notebook for simplicity. You can just select a Kubeflow experiment, give the notebook a name, and then click the compile and run button. So what is happening now is that Kale has validated the notebook, and now ROC, Arrikto's ROC data platform, is taking a snapshot of the current notebook, all of its volumes, so that your environment is completely reproduced in the pipeline steps. This is why, even though I just installed on the fly my libraries, the code will run seamlessly in the pipeline steps without you having to build the new Docker images. So Kale then compiled the notebook, created a pipeline, uploaded it to Kubeflow pipelines, and it started a new run. Let's go to Kubeflow pipelines using this link and see the pipeline running. Okay, so as you can see, here I have my true volumes that are basically new volumes that start from snapshots that were taken by ROC when I clicked the button. And my pipeline is starting. Let's give it a little bit of time to run while I go back to the slides and walk you through how Kale is actually doing all of this. So Kale is basically a Python package and a Jupyter Lab extension. It allows you to convert a Jupyter Notebook to Kubeflow pipelines in a completely UI-driven way, without the need of writing any kind of external SDK. How does it do that? Well, in the moment you click the compile and button, the run and compile button, Kale takes the notebook and parses it, analyzing all of the annotations you've added via the Kale UI. This turns into an internal graph representation that is parsed by Kale so that it can look at all the data dependencies between the notebook cells. So Kale detects these dependencies and then it takes care of marshalling the data between the pipeline steps for you so that the code execution is completely seamless, just like it happens in the notebook. And all of this is possible because Kale also takes care of generating a whole bunch of code that you would have, that you don't need to write anymore, because Kale is doing it for you. Note that Kale is an open source project that is hosted in the Kubeflow Kale GitHub organization. And we would be very happy to receive feedback and questions, and also contributions. Now, let's go back over to the pipeline that it is still running. It should be done very quickly. So notice how we already have 2 steps. You might remember that we tagged some cells with the load data annotation. And then we tagged some other cells with the detect dog annotation, specifying a dependency. So Kale was able to separate this code into multiple steps and then even branch out the training of the several different deep learning algorithms, because the dependencies were all referring to a common step. So you now have code that would have run serially in the notebook running concurrently in the Kubeflow pipeline. All of the logs are preserved. And also, let me go to a pipeline that was already concluded, or rather, I take this one since it has already completed. As you can see, I have a whole bunch of logs here that are basically reproducing the exact visualization that you would see in Jupyter. For example, here the CNN ResNet 50 in the notebook produces a visualization at the end of its computation to show one of the detected images, one of the dog breeds detected. So as you can see, Kale is able to completely reproduce even the notebook visualizations. So whether you are plotting with Matplotlib or interactive visualization with Plotly, all of this is preserved and reproduced in Kubeflow pipelines. Okay, so now that we've run a single pipeline, we would want to scale it up and run it as a hyperparameter tuning job. Let's go to the Katib notebook. In this specific notebook, we are skipping 2 of the deep learning algorithms, and we are running just over the ResNet 50. What we want to do is to parameterize the notebook with some input parameters and run the generated pipeline with Katib to optimize over a certain metric, so that we can optimize automatically the training algorithm. So we need 2 important things to do this: input parameters and an output metric. So with Kale, it is very simple to create pipeline parameters from the notebook. All you need to do is to define a notebook cell with some variable assignments and tag it with the Kale UI with the pipeline parameter tag. And then I'm scrolling down all the way to the bottom of the notebook. What you want to do is to have your code produce a metric that then will be exported by the pipeline and analyzed by Katib. So what you need to do is to print whatever variable your algorithm is producing and that you want to be used as an optimization metric, print it, and then tag the cell with the pipeline metrics tag. This is all you need. Once you have this, you can go over the Kale sidebar, enable the Katib toggle, and click on the Setup Katib job button. Now, as you can see, Kale provides you with this very simple to use UI that provides the input parameters. These are exactly the names of the variables I defined in the notebook cell. We have already filled the values we want to use, but you could insert here whatever values you want, from ranges, lists, integer, float, string values, what have you. Then I can select a search optimization algorithm and my search objective. Again, this is exactly the variable name we are printing in the pipeline metrics cell. That's all you need to do. I'm clicking close, and again, the compiler and run button. So now a similar thing happens as before. Kale validates the notebook, Rock takes an immutable snapshot at this specific point in time. Then Kale converts the notebook, uploads a new pipeline. And now here's what's happening. Kale is actually starting a new Katib job, a new Katib experiment, where each Katib run is actually a Kubeflow pipeline run. So this was not possible before. It is Kale that it is acting as a bridge between Katib and Kubeflow pipelines. Let's go see these experiments. So here I'm opening the Katib experiment page. Let's give it a few seconds to load up. As you can see, I have a new Katib experiment, and here a new Kubeflow experiment. They have the same names. They have one single run for the moment, again with the same name. So you have a one-to-one correspondence here. You see which are the input parameters that Katib decided to give as input to this pipeline. So I'm heading back over to pipelines. I see the pipeline being generated. It is starting to run. I can see even here in the config tab what are its input parameters. So this pipeline is running just like before, but with specific parameters that were given by Katib. Now, it would take a lot of time for us to monitor tens of pipelines running in this experiment. So let me head over to an experiment that we already ran some time ago. Okay, so this was an experiment created in the same way we did now, from the notebook, clicking a button on Kale. As you can see, I have several pipelines here that produced a specific metric. So this is the metric that we were printing from the notebook. Kale was able to interpret that and output this metric as an artifact. Let's go over also to the Katib experiment. This is the corresponding Katib experiment that was running. As you can see, we have many runs and how their performance varied over time. We have all of the runs even here with the corresponding metrics and input parameters. In the meanwhile, our experiment is still running, and you can see here, you can have a live view directly from the notebook about how many runs are running in this moment. And as soon as at least one would finish, you would see here a live view over what is the current best result as well, all from your notebook. Okay, so that was it for the hands-on tutorial. I hope you will have time to go through your code lab, play around with the code, start your own pipelines, and have fun. So let me go back to the slides. to summarize what we saw together today. So what have you learned today? Today, you have learned how you can run a pipeline-based hyperparameter tuning workflow starting directly from your Jupyter Notebook in a super simple UI-driven way. Kale is acting as the workflow tool that brings together notebooks, Kubeflow pipelines, and Katib experiments. This is a great simplification of how you can run machine learning workflows in a UI-driven way. Also, all of these exploit caching. And I will show you in a second how that I actually forgot to mention before. So we'll go back to the Kubeflow pipelines UI so that you can see that. All of this workflow, thanks to Rock, is exploiting our caching feature that is built on top of Kubeflow. And also, this allows you to collaborate faster and more easily. So let's head over back to the Kubeflow dashboard. This is actually something I wanted to show you, but forgot. So as you can see here, I am looking at the experiment that we had already run in the past. So I have several runs. I took one at random. And there is this little icon here. So this means that this pipeline was cached. Actually, these steps were cached. So why is this happening? The CNN Resonate 50 step is the only one in the pipeline that is dependent on some input parameters. It is the only part of the original notebook code that reads, that acts upon those parameters. Since Kale knows this, it also knows that the previous steps won't change that will never change across all of your runs. This means that running log data and the tech docs several times would be a waste of resources. So what we've done is we've extended the current caching implementation of Kubeflow that works over artifacts to work also over snapshots and PVCs. In this way, the running time and the performance of all of these pipelines is greatly improved. Okay. So back again to our summary, running pipelines from Notebook to Kubeflow in a completely UI-driven way with caching in order to accelerate your workflow dramatically. I would like to conclude by saying that in Arrikto, we are very passionate open source contributors. We've contributed to many components in Kubeflow, from Jupyter Manager UI to pipelines, to building our opinionated and super portable Kubeflow distribution, MiniKF. We've done lots of work to the authentication and authorization architecture of Kubeflow, and also many contributions to the Linux kernel to support our data platform. Kubeflow is a great community made up of many big companies. And as a community, we are always striving to find new contributors and new passionate users. So please get involved. You can find here lots of pointers from the GitHub organization to our Slack, Twitter handle, or write us an email to the Kubeflow Discuss Google group. We'll be happy to support you and onboard you. So thank you for staying with us. We really hope you'll have fun playing around with our tutorial. Make sure to head over our website and this quick link where you will find the slides and you could win some cool prizes. Thank you again, and see you soon.